I'm a member of the R&D team at European Thermodynamics working on the Powerdriver project. From the early stages of this project, I have been involved in defining the different materials within the thermoelectric generator and also evaluating the heat exchanger design and doing the relevant reporting for them. I have also been assisting with the final assembly of the prototype device and the system integration. Powerdriver is a collaborative research project which aims to develop an innovative, environmentally friendly thermoelectric power generation system for both automotive and marine applications that will harvest the waste heat from the exhaust gases in order to decrease the fuel consumption by 5% in the case of the passenger car. The objective of the project is to develop an exhaust system that will offer greatly improved environmental performance due to improved fuel efficiency and reduced emissions at a cost that is actually affordable to the end user. There are certain limitations associated with the project. Now, the whole system has to actually operate under harsh environmental conditions, that is vibrations or thermocycling. It also has to not affect the back pressure of the exhaust system and not compromise the engine balance.
I'm a member of the R&D team at European Thermodynamics Limited. My role in the project is to develop the joining technology for the silicide material. I also build the devices, characterize them, and then finally I'll build the final prototype device. There are several steps involved in assembling the final prototype. Furnace. We use a vacuum brazing technique to produce the silicide modules. The thermoelectric material has to be joined with a solder that has a higher melting point than the expected working temperature of the final thermoelectric module. As the module has to be taken to high temperatures for the manufacturing process, it has to be carried out in a vacuum to minimise degradation. The equipment is specially designed so that the sample can be heated and cooled very quickly. Cutting. The silicide materials have to be cut into small pellets to form the PN couples, but are particularly hard but brittle. This makes it difficult to cut large amounts of the material using conventional methods. A multi-diamond wire saw is used to cut the large amount of pellets that is needed for the prototype. Jig, making the pellets into a module. A bespoke jig has to be designed to hold the assembled components in place during the vacuum brazing stage. It is important that all the components are held in place, while an even pressure is applied to the assembly to ensure the ceramics of the final module are parallel. Heat exchangers. This is the hot heat exchanger. Modules are assembled onto this with a high temperature thermally conductive adhesive. This is the cold heat exchanger. This removes the heat from the system. It has been very beneficial to have a consortium of partners that spans across the EU. They've given us a wide range of invaluable knowledge to draw upon. For more information on the Powerdriver project, please visit the dedicated website.